In this section, we will talk about how you can analyze the vulnerabilities that appear in the Docker containers. And more specifically, let's have a look at the Docker threats and attacks. So, from a security point of view, it is quite important to have some knowledge about the Docker container threats and system attacks that can impact the Docker applications. So here I will show you multiple resources from which we will explore the Docker main container threats and main vulnerabilities that you can find in the Docker images and some services and tools that are related to Docker. So if you go to this page, cvdetails.com, and you go to the Docker page, you can see organized tables with all known Docker vulnerabilities by year and see some nice graphs. So nowadays, it is critical to ensure that the images you are running are up to date and do not contain software versions with known vulnerabilities. So this page will pretty much help you to find out all known Docker vulnerabilities by year and separated in different categories. So all the categories can be separated into three main most common attack sources that are vulnerable. So first, we can have direct attacks to the kernel, taking advantage of a vulnerability that has not been patched yet. Then you can have a denial of service attacks, and here the main problem is that the container might monopolize the access to certain resources such as the CPU, memory, and that could alternatively result in a denial of service. And finally, you should be very careful not to use Trojanized images. So if an attacker gets an image and Trojanize it with malicious code, both the Docker host and the data exposed within the container are all in risk. So going back to the page with all known Docker attacks, we can see a very comfortable graphs with the vulnerabilities by year, and you can actually see that, for example, for 2022, we had the year with the least vulnerabilities found. However, if you take a look at 2020, this is where actually Docker really took a hit and a lot of vulnerabilities were discovered but later on fixed. You can also see all the vulnerabilities by type. So you can see that the most common vulnerabilities are the ones from the executed code, denial of service, and bypassing. So take a look at this page at your own time, and from there you can really discover in detail all the Docker vulnerabilities that have been found. And also, if you're interested in any other type of tool and want to find out about the vulnerabilities of that tool, definitely feel free to refer to that page. So the containers will always share the same kernel and Docker host, so the container can exploit many vulnerabilities in the kernel interface to compromise the Docker host. So there are some known issues and threats inside the containers that you should be aware about. For example, your container would be under threat if it tries to download additional malware or scan internal systems for vulnerabilities or confidential data. Another way to put your container in risk is if it is forced to use system resources because that might block another containers. Another threat is called a dirty cow that exploits the Linux kernel and allows root privilege escalation on a host or container. You can also have attacks on insecure containers by MongoDB and Elasticsearch containers. Another very common problem is actually the buffer overflow in specific programming languages libraries, and this will allow the execution of malicious code. For example, vulnerabilities such as buffer overflow can actually give control to the hackers and allow their attacks. And finally, you can also get SQL injection attacks that allows the attackers to take control on the database container in order to steal some data from that database. And especially if you are working for a company providing financial services, this data could be quite valuable for you and for your business. So one of the most critical vulnerabilities in the Docker was discovered in 2019, and this is the CVE 2019 5736. This vulnerability allowed the attackers to overwrite the host runs binary and consequently to open the host with root access. So this vulnerability was actually discovered in the utility to run containers that is called runc, and this made it possible to obtain root permissions on the host machine. This attack was actually not blocked by tools such as AppArmor. However, it was possible to block this vulnerability by enforcing a specific mode and configuration of the namespaces. So you can see here that we have some number, and this is the number according to the Common Vulnerability Scoring System, CVSS, for which we talked about in the previous videos. And this is being used to measure the criticality of the threats. So this score here is pretty much based on factors like attack vendor, complexity of the attack, privileges, user interaction, scope, and so on. So let's see what are the key matrices for obtaining this number here. So for obtaining the criticality of vulnerabilities, we can also use matrices such as the assess vector, for example, and this pretty much refers on how the vulnerability has been exploited. So an exploitable vulnerability means that the vulnerable software is bound with a network stack, and this means that the attacker doesn't require local network access. And such type of vulnerability very often is called exploitable remotely vulnerability. And an example here could be, let's say, a buffer overflow. Another very important metric is the assess complexity, and this metric measures the complexity of the attack required to exploit the vulnerability once the attacker gains access to the targeted system. For example, if we consider the case with a buffer overflow in the internet service, this would be a vulnerability with high access complexity. Another very important metric is the authentication, and this metric analyzes the number of times the attacker that he or her needs to authenticate to exploit certain vulnerability. So according to this metric, we're measuring that an attacker is required to provide credentials before the vulnerability occurs. So in general, the fewer authentications are required, the higher the vulnerability score would be here, because the easier for the attacker would be to assess the system. Then we have the metric that measures the impact of the confidentiality from the information that the attacker gets when exploiting certain vulnerability. So confidentiality refers to limiting access and disclose information to authorized users as well as preventing access from unauthorized users. So here, the greater the impact on confidentiality is, the higher the vulnerability score would be. And finally, the final metric is the integrity impact, and this metric measures the impact on the integrity from a successfully exploited vulnerability. So the greater the impact on the integrity is, the higher the vulnerability score would be. For example, if an attacker can modify any file in the target system, at that point you would have a very high score. So let's look at one of the example vulnerabilities that have been discovered in Docker. So this is the Dirty Cow privilege escalation vulnerability in the Linux kernel. And this would allow to existing user without privileges to perform an elevation to administration privileges, right? So if somebody logs into your Linux system that is just a standard user, he could gain on his own access to administration privileges and perform actions that he doesn't supposed to do. So cow here refers to change to write, meaning that a standard user can actually modify the read-only objects, and by modifying those objects he can gain a root privileges. So the vulnerability used in the Dirty Cow is the one that exploits contents of the memory while the kernel is executing system calls and perform actions to the same memory address space. And so here on this page, you can pretty much see all the versions that are vulnerable to the Dirty Cow exploit. They're hopefully versions that nobody is using anymore, but by checking out this vulnerability, you can see what versions you should avoid. So you can find the Dirty Cow repository for Docker right here, and this repository pretty much is responsible for simulating that vulnerability on some Linux versions. So that's it. Thank you very much for watching, and I will see you in the next video.